My name is Ciara McCarthy. I'm the Global Marketing Director for EPS Global. I'd like to welcome you all to Bare Metal Basics, the first in our series of webinars, which are going to be moderated by Barry McGinley, who is our systems engineer for EMEA or technical sales engineer, whatever is required of him on the day. He's very versatile. So just to give you a bit of background on EPS, we're the open networking distributor of choice globally for a whole host of industries. We sit at the center of the open networking ecosystem, bringing together both the hardware and the OpenOS software to create turnkey solutions for our customers. We offer technical advice, configuration of software and hardware bundles. That's the switches, optics, cables, and more. We've been around for 20 years and we've 28 global locations, so we're never far away. So just a bit of housekeeping. We're respectful of your time, so we want to keep this webinar to around 30 minutes. So taking that into account, we're going to mute everybody just to minimize the disruption while Barry presents. And any questions that you have, you can just type into the chat window of Zoom. Barry will come to these questions at the end and answer them, and anything he doesn't get to, he will respond to you personally after the webinar. We will also be announcing the next 3 webinars in the series, and we'll also make the recording of this session available to you all afterwards in case you want to watch it again or share with your colleagues. So finally, just if anyone hasn't sent us their postal address yet, can they please do so? It's just so we can send you on our free gift. So that's it from me. Thank you for joining again, and I will hand you over to Barry.
Thanks, Ciara. Good morning, everybody, or good afternoon for some, because I know we have a contingent here from India due to the cancellation of data center transformation Mumbai. So I hope everybody's well in these turbulent times. So a little about myself. My name is Barry. I'm a network engineer, primarily worked on Cisco switches, and then for the last 2 years, I've been working in open networking for EPS. So the way it kind of works is customers will come in, talk to the sales guys, and then I'll come in and we'll talk about hardware. So we'll decide 10 gig, 25 gig, 25 gig, 100 gig, and then we'll look at the NOSes. That's what we call them, network operating systems, for the particular business case of the company. Then once we select a NOS, we'll look at virtual machines maybe, or maybe move to hardware, do a proof of concept with trial licenses and some trial hardware. And then we'll get to bringing in the system engineers from the NOS vendor, and then we'll work on implementation and configurations and things like that. So today, what we're actually going to talk about is the kind of bare metal open networking ecosystem. So we'll talk about the beginnings, where it came from. We'll talk about 3 foundations that are pretty important to the way this all works. That's the OCP, the Open Compute Project, the ONF, the Open Networking Foundation, and then TIP is the Telecom Infra project. We'll look at some terminology you may have heard before: bare metal, white box, bright box, and we'll have a look at merchant silicon as well, so switching ASICs. We'll look at software. I've split the software into 2 different areas. That is commercial software and open source software, and then they're split again in the commercial side. Then we'll look at the 3 areas that open networking is in at the moment. So that's data center, which it has been since 2011, carrier since 2016, they started working on projects, and now campus networks over the last year. So as Ciara said, conscious of time, so we'll push on. So in the beginning, there was Facebook. I was going to go back to 2006, 2007 here originally and talk about OpenFlow. It was a protocol that they worked on at Stanford University. And basically what it allowed to do was, so before, when we had normal switching, we had the control data plane and management plane in the one switch. The OpenFlow protocol allowed for the separation of the control and management layer, abstracted away to a controller. And then the data plane could just be bare metal switches that just transport the data at really, really quick rates. But we're going to start with Facebook. So 2009, and Facebook are offering a bunch of new services on their platform. And obviously with the image sharing and video sharing, their infrastructure is starting to struggle quite badly. So they get a team of engineers together with a brief of redesigning everything, their hardware, their software, racks, power supplies, the lot. So it took them 2 years, and it was completed in 2011, and it's still going in Prineville, Oregon. It was 38% more energy efficient and 24% less expensive to run. Now, you'd expect that. You'd expect that at the least from a new data center. But the thing to come out of this was that Facebook, Intel, and Rackspace published all their designs. So then, along with Goldman Sachs and a guy called Andy Bechelstein, they created the OCP, the Open Compute Project. So the OCP, the idea of the OCP was to kind of create a movement in hardware that would create creativity and collaboration, much like we saw with open source software. So you look at the Linux community out there, that was the idea behind it, to do with hardware. So the way it actually works is, if you become a member of the OCP, we're members ourselves, and any member can give in hardware specifications. No designs, just specifications. We'll say a 10 gig switch with 48 ports. Obviously, you have to get a little deeper than that. You actually have to hit 3 of 4 particular tenets: efficiency, scalability, openness, and having an impact on the open world as well. So once the hardware specification is there, companies can then give in design files for those specifications, and then products are built from the design files. So you get specifications, designs, then products, and then once we have products, they get moved to what's called the OCP marketplace. And I just want to show you real briefly the marketplace. So you'll see at the top we have products and facilities. That's individual products. We have integrated solutions. That's multiple OCP products to make an actual integrated solution. So I think in there we have spine and leaf. So say 25 gig and 100 gig switches in the one box. We have SIBA pods, which allows for software-enabled broadband access from the ONF. So it bunches all these products from the OCP together to create a solution. There's also there the circular economy. I'm not really going to touch on it today, but if you're interested in environmental issues, that's something that's quite interesting on how to reuse IT equipment. So if we go down and have a look at the products, so there's a nice tab here, products, network gear, and Edge Core. So Edge Core are the largest contributor to the OCP by a mile. So right, we've switches come up there. So the first one is a 571254X. That's a 10 gig 48 port switch. I think that was the first switch accepted by the OCP. It's actually end of life this year. 5812 now was taken over from it. But just at the bottom underneath, we see specifications. If you were to click in here, you'd actually see everything required to build a switch yourself. I wouldn't advise it, but you could. So it has all the design material, all the software material in there in different files. Okay, we go back here. So the last part to the OCP is that they have close ties with the ONF and TIP. So the OCP produces individual products, and then the ONF and TIP put them into platforms and end-to-end solutions. So we'll talk about them now. So the ONF, or the Open Networking Foundation, founded a month before the OCP, actually, in March 2011. And it was originally to look after OpenFlow, the protocol that allowed the separation of the planes, and to promote the general benefits of software-defined networking. 2012, they started work on the ONUS project, which was Open Networking Operating System. It's actually a controller for the whole kind of ONF ecosystem, which we'll touch on in a while. Then 2016, kind of big shift in what they wanted to do, and they started a project called CORD. So CORD is central office re-architected as a data center, and the central office is the carrier's last point at which they kind of touch the customers. So this is the last point where they do their residential broadband, they do their enterprise broadband, their mobile. So you'd have walked by central offices before and not known. They're usually grim, kind of grey buildings. It's only if you looked hard, you'd see fans on the back and maybe cameras on the front. So you'd see projects, you'd see devices like OLTs, optical line terminals, broadband network gateways, switches, routers in these central offices. So that's what Cord is what the ONF call a platform, so an exemplar platform. And then within the platform, multiple projects run. So ONS is a project that would run within Cord. Stratum, their operating system, is a project that would run within Cord as well, but they have multiple platforms. They're on all sorts of stuff, broadband, mobile, edge cloud, and next gen SDN projects, I should say. So this is kind of going from strength to strength. They've reference designs now. So the ones I have listed here, COMAC is converged multi-access and core. SEBA is software-enabled broadband access. Trellis is not an acronym for a change. That's quite nice. That's spine and leaf in the central office. But these are all actually being implemented now in production networks by companies AT&T, Turk Telecom, Deutsche Telekom, and Comcast. So it's starting to become a real success. And we'll touch on it a little bit later on actually as well. And the final one is the Telecom Infra project. So this is the new kid on the block since 2016. And this is looking after mobile. So it has three distinct areas. Access, that's your mast. Transport is the backhaul from the mast back to the data center. And then core and services, that's your actual data center. So there's I have some of the projects listed there. Within access, I suppose the big one that's people may have heard of is Open RAN. That's being implemented at the minute, and other companies running field trials. From the transport, from the backhaul, the image to the right there actually shows a project that's fairly far down the line, and it's the open optical and packet transport. So the idea of it, if you see on the image, I know it's quite small, you'll have a mast. Under the mast, you'll have a bare metal cell site gateway with an operating system on it. Then you aggregate them, multiple cell site gateways in the aggregation router, like a 5916 from EdgeCore. And then depending on distance, you'd use a bare metal optical transponder. So the Cassini, that's from EdgeCore as well. There's other companies that make it then into your core routers and then back to your data center. So it is an end-to-end solution. And all these products were in the OCP. So you see, it is an ecosystem and it's kind of collaboration. TIP has an exchange, which is similar to the marketplace that I just showed you from the OCP. Okay, some terminology. So we've bare metal. So bare metal is a switch that just comes with ONI, which is a bootloader. And that bootloader allows you to load NOSes, network operating systems, on top of it. So simply, it's a bare metal, it's a switch with a switching ASIC from Broadcom or Barefoot, and it allows you to put whatever NOS you want on top of it. Whitebox is a switch that comes with a NOS installed. So this is something we provide for our customers. It just takes one layer of decision making out of it for the customer. So say you go with Cumulus or Ocnos from IPI or Pika8, we'll install that operating system and then the license on top of it for you and package it off and send it to you. Cumulus also offers this service. It's called Cumulus Express. Just takes one layer of awkwardness, I suppose, out of it. Brightbox, just to describe Brightbox, actually, I'll explain who Acton are. Acton Group are a Taiwanese ODM, original design manufacturer, and they make switches for, if you've been in switching for a while, you've used an Acton switch. They make switches for just about everybody. And what they do when it comes to Brightboxes is they just put a different label on it. So HP and Dell would be Brightbox. So it's the same bare metal switch that you're getting, except with a logo on the front of it. And then Dell or HP will put their own operating system on top of it. Acton Group spun out their own bare metal manufacturer called EdgeCore. And there's a bunch of them out there now. And they're usually kind of Taiwanese companies. Delta, Quanta, and Celestica are a couple of other ones. So merchant silicon, I just wanted to touch on merchant silicon. It was kind of important to the bare metal switches. So basically merchant silicon is off the shelf chips. So these are switching ASICs. And last year, 56% of switches that were shipped worldwide contain merchant silicon. And they're looking at somewhere around 65% this year. Cisco, their new 400 gig switch comes with their operating system on it. but it also comes, there's an option to have it with merchant silicon as well. So that allows for companies that have bare metal or white boxes or bright boxes in their network to have operational unity and be able to use Cisco if they wanted to. And obviously as well, if you're looking at Cisco as far as how long it takes to make a switch, so they have to work on the fans, the boards, the PSUs, the operating system itself, even the metal. Whereas, so the time they can give to the switching ASIC isn't as much as these guys. Broadcom, Cavian, and Barefoot, this is what they're doing. So they produce better chips in way, way faster time.